Hey guys, and welcome back. So far we have talked about how to count the atoms in a chemical reaction, and now that we know how to count them, today we're going to talk about balancing chemical equations. So we've talked a little bit about the law of conservation of mass, and today we're going to see how that applies to our chemical reactions. So let's go ahead and jump in. So just a reminder, the law of conservation of mass states that matter is neither created nor destroyed. So in chemical reactions, this means that the amount of particles in the reactants is equal to the amount of particles in the products. So let's say you have 20 particles in the reactants, you're going to have 20 particles in the products. It basically just means the amount of substance of your reactants equals the amounts of your products every single time. Because, again, law of conservation of mass can't be created or destroyed, so that means it has to balance out. Okay, so when we're balancing equations today, we just have to make sure that there's the same number on the left as there is on the right. So just a reminder, in a basic chemical equation, your reactants are on the left-hand side and the products are on the right-hand side. So on the left we have our reactants as what goes in, and on the right we have our products which come out. And that is just a review because we've already talked about that when we got our intro into chemical reactions. And also just a reminder about the difference between coefficients and subscripts. Again, we've been counting atoms, so we've seen this before, but we just need to make sure we're on the same page. The subscript tells you how many atoms or ions are within a compound, and the coefficients tell you how many moles or formula units. We haven't talked about moles yet. So basically what it's just telling you is how many of each compound or molecule there is, right? So here we have two subscripts, like H2O2. This means there's 2 atoms of hydrogen, 2 atoms of oxygen. The coefficient means that there's 2 of these H2 molecules. Okay, so the coefficients we know we multiply by our subscripts, and if there is no subscript, it's a 1, and so we multiply the coefficient by the 1. Okay, so coefficients go in front, subscripts are the small numbers on the bottom. So here's our rules for chemical equations. Because of our law of conservation of mass, they have to be balanced. Okay, so this just means that there's the same number of each kind of atom on both sides. So if we take a look here, we have CH4 plus 2O2 will yield CO2 plus 2H2O. And this is a balanced equation because on both sides we have 1 carbon, 4 hydrogen, and 4 oxygen. And since the number of atoms of each element are the same on each side, this is a balanced equation, okay? This is where counting atoms comes in, right? We spent 2 days on counting atoms just to make sure we knew how to count them. So here, the carbon comes from 1, it's got the 1 subscript. 4 hydrogen comes from the 4 subscripts. And then 2 coefficient for the O2, 2 times 2 is 4, okay? So making sure we know how to count them, making sure we can balance them, and I'm going to teach you how to do that, okay? And you would just do the same for the right-hand side as well. So remember that when we are counting atoms, we have to multiply the coefficients by the subscript. So if there is a coefficient, we have to multiply it by the subscript. And remember, if there is no subscript, we assume it's 1. So we're multiplying that coefficient by the 1. Okay? So now, when we are balancing chemical reactions, there are some things we can change and there are some things we cannot. We can change the coefficients. We cannot change the subscripts because changing the subscripts will change the compound. So the subscripts have to stay. So when we are balancing these chemical reactions, you are not going to touch the subscripts. They will be the same each and every time. So don't worry about changing the subscripts. And again, that's the small letter behind the element. What we are going to change is going to be the coefficients. So the coefficients that go in front of the compound or the element, these are going to be able to be manipulated so that we can balance these chemical equations. And this is just a little depiction here that shows us basically what each compound means. We've talked about compounds before, but it's just showing you kind of what it means to have a coefficient. So like I'll look at these two on the bottom. So we have CO2 here. That would mean 1 atom of carbon, 2 atoms of oxygen. And then if you have 3 CO2, it just means you have those 3 molecules now of carbon dioxide. So that's what our coefficient tells us, just how many of each molecule there is, or compound. All right, so here are the steps for balancing chemical equations. You definitely want to make sure you write these in your notes so that you have them, because these are the steps we're going to follow. Number 1, you are going to write the correct formula for the reactants and the products. Most of the time you will already be given the formula, but remember, we know how to figure out the formula now of ionic compounds, covalent compounds, so it's possible you could be given word problems where you have to first figure out the formula and then balance the equation. So we're going to write the correct formula of the products and the reactants, okay? Again, we do not change the formulas, we do not change the subscripts. Then we are going to find the number of atoms for each element on the left side. Okay, so we're going to find the number of atoms on our reactant side first, and then we're going to compare those against the number of the atoms of the same element on the right side. So remember, law of conservation, if you've got a carbon on the left, you're going to have a carbon on the right, and they are going to have to balance out. Then we're going to determine where to place coefficients in front of the formulas. So remember, the left side must have the same number of atoms as the right side. We cannot manipulate those subscripts, but we can change the coefficients. Then you are going to check your answers to see if, number 1, the number of atoms on both sides of the equation are balanced, and number 2, the coefficients are in the lowest possible whole number ratio, so they're reduced. So like if you end up with an equation or with a balanced equation that has coefficients that can be reduced to a lower number, you should do so, okay? All right, so just some tips and tricks. You're going to write out an inventory list. That's just basically the number of elements that you have or which elements you have in your reaction. And then you're going to work from the top of the bottom. Make adjustments to the other atoms impacted by any coefficient changes. And if you get to the end and everything balances except for oxygen, you have to double all the coefficients and try again. So the reason for that is oxygen is diatomic as an element. So if oxygen exists on its own, like by itself, it's not bound to anything, it's always going to be O2. And because of that, it can't balance with an odd number. So if you have O2 that needs to be balanced, you're probably going to have to double it and start again. So if you get to the end and you find that your oxygen is not balanced, you're going to have to double it and then do it all again. Okay? And of course, I'm going to show you some examples. So if this is a lot of information, of course, we're writing it down so we can use it to help us figure these out. But of course, I'm going to do some examples here with you too. And here is a suggested order of atoms in your inventory list. Honestly, it doesn't matter how you write your inventory list. Honestly, I start just with the elements on the left, and then I just do them in the same order on the right, and I'll show you what I mean here in just a minute. But if you want to have a specific way that you write them out, you can do metals, then nonmetals, hydrogen, and then oxygen. And remember, for oxygen, if it doesn't balance, we're going to double those coefficients. Okay, so let's take a look at an example. So here we've got B2 plus W2, and W is tungsten, will yield BW3. Okay, so this is how we are going to do this. The first thing I'm going to do is write my inventory list. Okay, so on my product side, or my reactant side, I have 2 boron, and I have 2 tungsten. Okay, this is what we mean by an inventory list. We just list all of the elements present and how many of them are present. Okay, so I'm going to put a line here to help me denotate. And here I've got 1 boron and 3 tungsten. Okay, now I can tell that this is not a balanced equation because all of these have to equal the same number. So if I have 2 on the left this number should also be 2. If I have 2 on the left, this number should also be 2. Now, it's not balanced, so we're going to have to figure out how to balance it. Okay, so we're going to have to manipulate the coefficients. Now, and I just said if this is 2 on the left, this should also be 2. That's not quite correct. I think I worded that a little bit wrong. It has to be equal. Okay, so whatever number is on the left has to be on the right. And these numbers can change and will change. Okay, so at the end, as long as they are equal, that's when you know you have balanced your equation. Okay, so I always start by looking at a low number and seeing if it needs to be bumped up. So I'm going to start with boron here. So he has 2 on the left-hand side and only 1 on the right-hand side. So I'm going to go ahead and manipulate my coefficient so that I can change this number of boron to 2 to match the 1 on the left. Okay, so now that I have this 2 here as a coefficient, I can change these numbers, because since we've added that coefficient, they are going to change. So now, instead of having 1 boron, I will have 2. And instead of having 3 tungsten, I'm going to have 6. Because remember, 2 times 3, so our coefficient times our subscript is 6. Okay? Well, now my borons are balanced, because I have 2 on the left and 2 on the right. But my tungstens are still unbalanced because now there's 2 on the left and 6 on the right. So now I'm going to see what I can do about balancing this tungsten. Here, because we have 2, well, what can I multiply 2 by to get 6? It's going to be 3, right? Because 3 times 2 is 6. So now that I have this 3 in front of my tungsten here, it doesn't affect my boron because boron's by himself on the left-hand side. So we don't have to change anything about him because he still has his 2 subscripts, so he's still 2. And now our tungsten is going to be 6, okay? So now our borons are balanced and our tungsten is balanced. So this is a balanced equation, okay? So now let's do another example. And I'm going to try to do this one kind of quickly because we are running out of time. So I have C plus S8, so carbon plus 8 sulfur will yield CS2. So same thing, I'm going to make my inventory list. So I'll have C, and I have S in my reactants. And then I have C and S in my products. So here I have 1 carbon, and it's a little bit hard to see, but I have 8 sulfur. And on my right-hand side, I have 1 carbon, and I have 2 sulfur, okay? This is not balanced. So the carbons are balanced, but my sulfur is not. So I have to balance it in order to get this chemical equation balanced, okay? So since the sulfur here is 8 and my sulfur over here is 2, I'm always going to start by trying to bump it up, right? Because we know we have to at least get to the point where we have 8 sulfur, or we at least match these. And in order to match these, this has to come up because we can't get rid of the 8 on this side because it is a subscript, and we can never really go down, we have to go up, okay? So I'm going to ask myself, what times 2 will give me 8? It's going to be 4. So I'm going to add 4 as a coefficient. Now, again, since I've added a coefficient, I want to make sure that I'm updating my number of atoms as I go along. So 4 times the 1 subscript for carbon is going to be 4. And then 4 times 2 for the sulfur is going to be 8. Okay, now my sulfurs are balanced, but my carbons are unbalanced. So now I have 4 on my right-hand side. What can I do to my left-hand side to balance my carbon? Well, I know that 4 times 1 is 4, which will give me 4 carbons and then 8 sulfur. That is balanced because now on my reactant and my product side, I